Hello everyone. This is the second video on alkanes where we are discussing nomenclature, the rules of naming alkanes. So let's focus on the first molecule. If I number it the way I have shown here, then at the third position I have a substituent and it is a 6-carbon parent chain. So it is a hexane, and at third position I have a 3-carbon chain, 3-isopropyl hexane. That should be the name. If I number it the other way, 3, 4, 5, 6. So I get again 6 carbons in the longest chain, but I have two substituents. One at the second carbon, I have a methyl group. Second, at the third carbon, I have an ethyl group. So the rule says that we should choose that one which gives us more number of substituent, which is clearly the second case. So the name of this compound would be 3-ethyl 2-methyl hexane because 6 carbons. Fine. Now let's go to the next example. When you have more than one substituent attached to the parent chain, list the substituents in the alphabetical order. What does that mean? It means if you have ethyl substituent and methyl substituent, so ethyl would get precedence over methyl because E comes earlier in the alphabets as compared to M. And then number the chain in the direction that produces a name containing the lowest substituent number. What does that mean? So let's go 1, 2, 3, 4, 5, 6, 7, 8. So it's an octane. At the fourth carbon, you have an ethyl group. At the sixth carbon, you have methyl group. So the name would be 4-ethyl 6-methyl octane. Fine. If I choose the other type of the numbering, like going from left to right, 1, 2, 3, 4, 5, 6, 7, 8. So I would have 5-ethyl 3-methyl octane. Now which one I should choose? Which one I should go for? So I should go for the one which gives us the lowest number of the substituent. You see here 4 and 6, here 5 and 3. So lowest one is third one. So we will choose this one as per the rules. Remember that they are the rules which have been designed so that there would be a uniformity when we are naming them. Anywhere we name them, the compound remains the same. Okay. Now, if you have 2 or more substituents which are the same one, then use the prefix di, tri, tetra, etc. to indicate the number of that type of the substituents. For example, in this molecule, so number it 1, 2, 3, 4, 5, 6, 7, 8. So this is 2. At second position, you have a methyl group. At third position, you have a methyl group. 2, 3 dimethyl octane. Fine. Now, if you have this type of the scenario as shown in the next example, 1, 2, 3, 4, 5, 6, 7. So you have substituent at third position and at sixth position, right? At sixth position, you have a substituent. At third position, you have these substituent. At sixth position, you have a methyl group. At third position, you have a methyl group. So you have dimethyl. Not only dimethyl, but you have to tell where that methyl is located. So 3, 6 dimethyl and 3-ethyl, right? So 3-ethyl 3, 6 dimethyl heptane. Fine. On the other side, if I choose the other type of the numbering, 2, 3, 4, 5, 6, 7, it gives me the name. So we have like methyl at second carbon and at fifth carbon, and an ethyl at fifth carbon, right? So we'll write it as 5-ethyl 2, 5, dimethylhaptane, because the length of the parent chain is the same from both the sides. So it is haptane in both the cases. Now, which one we should go for? We should go for the one which gives the least number, like least number of substituent of that type, as we have lowest substituent number. So lowest substituent number 3, 3, 6, 5, 5, 2. So 2 is the lowest number, which is there any number in this which is lower than 2? No. So we will go for this one as compared to this one. So 5-ethyl 2,5-dimethyl is the correct one because it gives the lowest possible number to a substituent. Fine. Now next, when both directions give the same substituent number, then the first group listed, which means the one which comes first in the alphabetical order, gets the lower number. Okay, so let's see how this goes. So if I go 1, 2, 3, 4, 5, 6, 7. If I go the other way around, 1, 2, 3, 4, 5, 6, 7. Fine. Now we have substituent ethyl and methyl. Which one comes first in the alphabetical order? Ethyl, right? So the ethyl should get the lowest possible number in the substituents when both directions give the same substituent numbers, right? Because we are getting 3 and 5 in both the cases. You see, we have substituents at 3 and 5, 3 and 5. So which one we should go for? We should go for the one which gives the lowest possible or the lower of the two numbers to the first group that is listed. So there are two groups, ethyl and methyl. Which one would be listed first as per alphabet? Ethyl. So we will choose where ethyl will get the lower number, right? So 3-ethyl 5-methyl-haptane, right? That is the correct number. I hope this clarifies the rules. With the examples, we have done this. So I would encourage you to try more examples. And if you're looking for more practice problems or something, please drop a comment below. I would definitely share more examples with you. Nomenclature for complex substituents. So sometimes the substituents are not as simple as ethyl or methyl. Sometimes the substituents are complex substituents, just like this, which is isopropyl group. So how to name in such case of the molecules, how would you name them? To name such molecules, we should treat the substituent as a mini parent. Okay. Firstly, you follow all the rules, look for the longest chain and all that stuff. And then you treat the complex substituent as a mini parent and start numbering in it. Okay. So in this case, suppose just for your example, I can tell you. So we'll number it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a decane. So at third carbon, you have the substituent. Okay. Third carbon, you have the substituent, right? So this is 3 something and then decane. So when you have a complex substituent, you write that in the parentheses, in the brackets. Okay, so this would be 3 and then the substituent would be in the brackets or parentheses and then decane. Okay, now what should be in parentheses? How would we write it? We will write it by numbering the carbon that is connected to the parent chain. So this is the parent chain. The carbon of the substituent which is connected to this parent chain should always be given number 1. Okay, so give this number 1. Then this is 2. On either side it is the same, length of the chain is the same, so you can go either side. So you will write 1, what is it? Methyl, 1 methyl ethyl decane. Right? So It has 3 carbons but cannot be simply called a propyl because it is not propyl, it is isopropyl. So you can use common names if you are familiar with them. Then you can write 3-isopropyl decane. That is the simplest name. 3. So common names are permissible for such substituent: isopropyl, tertiary butyl, isobutyl. So 3-isopropyl decane. That is also the correct name as per IUPAC rules. Choose the longest chain. See the locant to which the complex is attached. So this is the locant to which the complex is attached. Then treat the complex as mini parent. So that's why we have numbered it separately as 1, 2. Assign number 1 to the carbon of the complex substituent from where it is attached to the parent, right? And when naming the complex substituent, place parenthesis around the name of the substituent, right? So this is 1-methyl-ethyl as we have already discussed. So if this is the parent chain and you have this type of the substituent, complex substituent attached, obviously you are going to give number 1 to the carbon from where it is connected to the parent. And then you can go either side, but you will go to that side which give you the longest chain. So that is why I have chosen that side. At first carbon, I have methyl group. So 1-methyl, and the longest chain comprised of 3 carbons. So propyl, and whatsoever the parent would be, that name would be written here. So is the case here. This carbon would be the number 1 carbon because it is the one which is connected to the parent. And then at second carbon, you have the methyl group attached. So 2-methyl, the longest chain is composed of 3 carbons. So 2-methyl propyl because 3 carbons are there, right? So if you have a complex substituent like this, the carbon next to the parent would be given the number 1. Then you go on either side, it is only 1 carbon more, so it doesn't make a difference. So 1, 2. At first carbon, you have 2 substituents. So 1, 1, because there are 2, so that's why you have to repeat 1, 1, dimethyl, and then ethyl, because it is the longest chain is composed of 2 carbons, right? If the complex substituent has di, tri, etc. as a part of the branch, it is included in the alphabetization. Normally when we have just simple chains, and suppose I have dimethyl and I have ethyl, I don't look into this D. I compare methyl with ethyl. But when it is a part of complex substituent, then we do consider this D with E. In that case, dimethyl would get preference over ethyl, right? So here in this case, you have at third carbon, you have ethyl, that is from the parent chain. But the complex substituent is the one which is connected to the 5th carbon. So 5, 1,1-dimethyl, ethyl, then 3-ethyl octane. So I hope this clarifies the rules of nomenclature. If you have any confusion or you cannot answer any question related to nomenclature, you're finding it difficult, so please write to me in the comments. I will get back to you as soon as possible. So I'm leaving this question for you. You can solve this in your own time, and you can share your answer with me in the comments. Thank you.